Hi everyone, welcome to IGCSE Study Buddy, where you can revise chemistry topics from the Cambridge IGCSE syllabus. If you are enjoying our videos so far, please don't forget to hit the like button and subscribe to our channel. In this video, you are going to learn part 1 of topic 8, the periodic table. The periodic table is a table that arranges all chemical elements in a way that can help us predict their physical properties and chemical reactions. Let's first learn about how these elements are arranged. The elements of the periodic table are arranged in rows called periods and columns called groups. Just a quick recap. The elements in the periodic table are displayed with their atomic number, which is the number of protons they have, and their relative atomic mass. So, the elements in the periodic table are organized in order of increasing proton number, which is also known as the atomic number. The atomic number increases from left to right across each period and from top to bottom down each group. For example, lithium has 3 protons, beryllium has 4, boron has 5, and so on. The proton number is the smaller number near each symbol. Periods are the horizontal rows in the periodic table numbered 1 to 7. The period number indicates the number of electron shells an atom has. Let's take lithium for example. Its atomic number is 3, so its electron configuration is 2, 1. Remember, there can be a maximum of 2 electrons in the first shell, 8 in the second, and 8 in the third. Since there are 2 shells used, we know that lithium belongs to period 2. So, in the elements of period 2, like lithium and oxygen, the atoms have 2 electron shells. In period 3, like sodium and chlorine, they have 3, and so on. As you move from left to right across a period in the periodic table, the character of the elements change from metallic to non-metallic. You may have noticed the red stepped line on this periodic table. This line separates metals from non-metals, with the non-metals to the right, except for hydrogen. So, on the left side of the periodic table, as shown in blue for illustration, are the metals. And on the right side of the periodic table, as shown in peach for illustration, are the non-metals. Metals are elements that tend to lose electrons to form positive ions in chemical reactions. Metals are typically good conductors of heat and electricity. They have a shiny appearance. They are malleable and ductile, which means that they can be shaped or bent. They generally have high melting and boiling points. Non-metals are elements that tend to gain or share electrons to form negative ions or covalent bonds in chemical reactions. Non-metals are typically poor conductors of heat and electricity. They have a dull appearance. They are brittle in solid form, and they generally have low melting and boiling points. So, as you go across a period, elements gradually lose metallic characteristics and gain non-metallic characteristics. We will learn more about metals in the next chapter. Groups are the vertical columns in the periodic table. Groups show how many outer electrons each atom has. Let's take lithium for example. Its atomic number is 3, so its electron configuration is 2, 1. Since there is 1 electron in its outer shell, we know that lithium belongs to group 1. So, group 1 elements have 1 electron in their outer electron shell. Group 2 elements have 2 electrons in their outer shell, and so on. The elements in the last group, that is group 8 or group 0, however, are an exception to this rule, as they have 2 or 8 electrons in their outer electron shell. Next, group number and ion charge. The group number of an element in the periodic table is related to the number of electrons in its outermost shell and helps determine the charge of the ions it forms. Elements in groups 1 to 3 have 1, 2 or 3 electrons in their outermost shell. They tend to lose these electrons to achieve a full outer shell, forming positive ions or cations. Remember, in chapter 2, we learned that it is easier for elements to lose electrons than to gain them when they have fewer electrons in their outer shell. Group 1 elements have 1 electron in their outer shell and forms 1 plus ions, example Na+. Group 2 elements have 2 electrons in their outer shell and forms 2 plus ions, example Ca2+. And group 3 elements have 3 electrons in their outer shell and forms 3 plus ions, example Al3+. Elements in groups 5 to 7 have 5, 6 or 7 electrons in their outermost shell. They tend to gain electrons to achieve a full outer shell, forming negative ions or anions. Remember, in chapter 2, we learned that it is easier for elements to gain electrons than to lose them when they have more electrons in their outer shell. In group 5, elements have 5 electrons in the outer shell and forms 3 minus ions. Example N3-. In group 6, they have 6 electrons in their outer shell and forms 2 minus ions. Example O2-. And in group 7, they have 7 electrons in the outer shell and forms 1 minus ions. Example Cl1-. In group 0, these elements have a full outer shell of electrons. They are generally stable and do not form ions easily. In summary, the group number indicates the number of electrons in the outermost shell and whether the element will lose or gain electrons to form ions. Next, similar properties in group elements. The outer electrons are mainly responsible for the chemical properties of any element, and therefore elements in the same group have similar chemical properties. This is because they have the same number of electrons in their outermost shell. This similar outer electron arrangement leads to similar ways of reacting with other elements. This is because in a reaction, it is the outermost electrons that participate in the chemical reaction. For example, all elements in group 1 have 1 electron in their outer shell, making them react in a similar way with water. The position of an element in the periodic table can be used to predict its properties based on its group and period. This is because the periodic table has patterns or trends in how elements are arranged, and these patterns help us predict how elements will behave. These trends can be seen down groups and across periods. Some of the properties of elements that we can predict using the periodic table are boiling point, melting point, density, and reactivity. Let's consider the elements in group 1 as an example. Lithium is at the top of group 1, sodium is below lithium, and potassium is below sodium. So, if we consider the reactivity trend down the group, reactivity increases as you go down the group. Lithium reacts with water relatively slowly. Sodium reacts more vigorously with water. Based on this, we can predict that potassium will be even more reactive than lithium and sodium. Lastly, identifying trends in groups. If we observe the reactions of, say, the group 1 metals with water, we will notice that lithium reacts slowly with water, produces fizzing, and moves on the surface. Sodium reacts more vigorously than lithium with more fizzing and faster movement. Potassium reacts even more vigorously, burns with a lilac flame, and moves rapidly. Based on the above observations, we may identify a trend occurring as you go down the group. That reactivity of group 1 metals increases as you move down the group. Now, given this information about the first 3 elements of the group, we may predict that the lower group 1 metals will react even more strongly, and this may be confirmed by observing their reactions with water. Rubidium reacts very violently with sparks. The reaction is more vigorous compared to potassium. And cesium causes a violent explosion. Overall, the pattern shows that metals at the bottom of group 1 are more reactive than those at the top. That concludes part 1 of topic 8, the periodic table. Are you enjoying our videos? Are they helping you? Here's a way you can show your appreciation and support our continued efforts. You may use YouTube Super Thanks to send us thanks. Hope this video helped you. Please share your thoughts and suggestions in the comment section. Thank you for watching, and please don't forget to subscribe to IGCSE Study Buddy for more revision videos. Bye.